The future of work is automated. Welcome to Aivora.
In 1996, the Ariane 5 rocket exploded 37 seconds after launch. The reason? A tiny software bug, an integer overflow. The total loss, over $370 million. This bug could have been caught before launch. But it wasn't. But here's the thing, we've had a tool that could have prevented this for decades. It's called formal methods, using math to prove software is correct. Engineers know it works. So why don't they use it? Which means every day we build planes, medical devices, and self-driving cars on software that might have hidden flaws. The question is, what's really stopping engineers from using formal methods? That's what this video will answer. Formal methods aren't some academic fantasy. Amazon uses TLA Plus to verify critical parts of AWS. Microsoft uses Z3. Even NASA uses them for Mars rovers. They work. But outside a few tech giants, almost nobody touches them. Take Toyota's unintended acceleration scandal. In 2009, cars sped out of control. The official cause? Floor mats. But a jury found that software bugs, a stack overflow, were the real culprit. Formal methods could have found that bug. So why not just use a language like Spark-Ada? It's built for formal verification. Airlines use it. The US Army uses it for missile systems. But it's hard to learn. And it's even harder to fit into existing workflows. Here's what I found, the real barrier isn't technology, it's culture. Engineers are trained to test, not to prove. Formal methods require math that most developers abandoned after college. It feels like a foreign language. Companies also see formal methods as too slow. A verification project can double development time. In a world obsessed with shipping fast, that's a non-starter. But what nobody tells you, the cost of a bug in production is often higher. Therac 25. 1980s, a radiation therapy machine killed 6 patients because of a software race condition. Formal methods could have caught it. The tragedy forced the industry to rethink, but only slightly. Most still don't use proof. There are dozens of formal tools, TLA+, Alloy, Coke, Spin, Z3. Each has a different approach. Some are good for protocol verification. Others for algorithm proofs. But every tool comes with a steep learning curve and a lonely community. Drop a like if this is surprising you, because most people don't realize how close we are to a safer software world, yet we refuse to use the tools. The resistance is real, and it's costly. But there is a path forward. Some teams have cracked the code. Amazon doesn't verify everything, they use lightweight formal methods only on critical paths. A few hours of modeling can catch months of debugging. It's about picking the right battles. Facebook built Infer, a tool that uses formal analysis techniques to find bugs in code automatically. It runs as part of their CI pipeline. No math required from developers. That's the secret, hide the proof, get the benefit. Microsoft's Dafny lets you write regular code and add contract annotations. Then it automatically proves your program is correct. No PhD needed. But adoption is still tiny. The ecosystem is missing tutorials, plugins, and community. The truth is, formal methods and testing are not enemies. Testing covers everything you can imagine. Formal methods cover things you never imagined, corner cases in parallel systems, race conditions, overflow errors. They complement each other. In 2019, SMT solvers like Z3 are getting faster and easier to use. They can check billions of possibilities in seconds. The technology is ready. The missing piece? Education. Most computer science programs still don't require formal methods. A few universities, like Carnegie Mellon and ETH Zurich, now offer mandatory formal methods courses. Graduates from those programs are changing industry. But it will take years before this becomes standard. Until then, most bugs stay hidden. If you're building critical software, hit subscribe. I break down how to make systems safer every week. We'll cover real tools, real case studies, and the hidden techniques that save billions. Don't build on shaky ground. The future is already here. AI is starting to help write proofs. In 2019, researchers used machine learning to guide theorem provers. Soon, formal methods might be as easy as pressing a button. But only if we demand it. Next up, how NASA used formal methods to land rovers on Mars. We'll look at the code that survived a rocket launch and a parachute landing, all verified by math. Subscribe so you don't miss it. Because some bugs are sky high.